All right, so the recording has started. And then, okay, so we were over here. Were there any problems that you had trouble with in particular?
I was confused on 10 and 11.
Okay, yeah, let's do 10 and 11. Alina, I just want to make sure I finish this one first so that we're not jumping back and forth, and then we'll go back to
that's
that
fine,
one.
that's
All right.
fine.
Okay, all right, 10 and 11. These are interesting ones as well. These require thought, and okay, once again, what I'm going to do is, you know what, I'm just going to search up snipping tool. Snipping tool is much easier than this Windows snip and sketch new business that they've put out. Okay. Okay, number 10 and number 11. Okay. Let me open up my notebook because I'm probably going to get stuck while I'm doing this problem. Just so I can remind myself how I did it, because I don't want to waste your time, that's all. So number 10 and number 11 is, okay, perfect. All right, I remember this one. So if we go to paint, okay, good. So you guys can still see my screen, right? Okay, all right, so what we're trying to do is find, we're trying to find K such that the given line is tangent to the graph of the given function. Okay, so what we want is we have, so for the first one, let's look at number 10 real quick. We have x squared minus kx, which is going to look something like this. I don't know where it's going to cross. It's going to look like a quadratic function. It's going to look like a parabola. And we want it to be tangent to y equals 4x minus 9, which might look something like this. So we need to figure out at what points, first of all, we need to figure out where this is tangent. Okay. So what we're going to do is first, the tangent line at any point for f of x is f prime of x. And the derivative of f prime of x is what? 2x minus k. Right? Okay? All right. Now what you have to think about is the slope of this point is what we're concerned with, right? Because the slope of this line is m equals 4, meaning that whatever points we're looking at, the slope of this line, m equals 4, has to be equal to the derivative, because derivative is slope, right? So 4 equals 2x minus k. Now what we have to think about is, what is k equal to, right? So in generic terms, k is just 2x minus 4. But that's not enough. We have to figure out what values, specifically what values is this true. So when we do this, what we have to do is think, okay, does everyone understand up to here so far? Because in these types of problems, it's very easy to get lost. So once again, stop me. Please stop me. Don't let me go on. Does it make sense what I did so far? Or no? You guys look confused. I can tell.
Yeah, I'm a little confused.
Okay, all right. Okay.
Point.
So here. So you take the derivative. Let me copy and paste the word. Show this. Actually, I don't think I'll be able to copy and paste it. But
no, it's okay. Yeah, it's okay.
So we're trying to find the value of k such that the given line, so this line, is tangent to this graph. So whenever we're dealing with tangent lines, we always take the derivative. The tangent line of f of x at any point is f prime of x, so we take its derivative, which is 2x minus k. Good so far? Okay. All right. The next thing we have to realize is if we want the tangent line to be equal, or if we want this line to be tangent to our function, that means we need this line's slope to be equal to the slope of this function. In other words, we need the derivative of f of x, so we need 2x minus k to be equal to the slope of this, which is 4. That's why we said 4 equals 2x minus 4.
Oh, okay, yeah, that makes a lot more
Then
sense
k
now.
equals 2x minus 4. So in generic terms, we know what k is, but that doesn't, we can't finish there. We need to give a definitive value of k. How do we do that? Well, the first thing I'm going to do is substitute k back into f of x. F of x is equal to x squared minus 2x minus 4x, which is equal to x squared minus 2x squared minus, plus 4x, right? And that's equal to minus, oh, Roshi dash is here, minus x squared plus 4x, right? Good so far? So that means f of x is really minus x squared plus 4x. Now here's the thing. To really figure out the points specifically at which the tangent line is equal to this line, we need to figure out when this line is equal to f of x. What we're going to do is we're going to set f of x is equal to negative x squared plus 4x. We're going to set this equal to our line here, which is 4x minus 9. What this will allow us to do is figure out the points at which the tangent line actually touches the function. Because yeah, sure, the derivative, we figured it out that it's equal to each other, but we don't know at what point specifically. So that's why, the reason why we're doing this is because it'll allow us to find the specific x value at which it's equal to, and then once we find that x value, we can substitute that back in here, and then we can find k. So if we set negative x squared plus 4x is equal to 4x minus 9, so we'll say 0 is equal to x squared minus 9, right? Does this make sense so far? This is another point where I myself get confused, and it takes time for me to wrap my head around this. So okay, so 0 equals x squared minus 9. That means x equals plus or minus 3. And once again, I skipped a step, but you know why that works. X equals plus or minus 3, meaning that this tangent line, obviously I didn't draw my graph properly, but at x equals positive 3 and x equals negative 3, the tangent line this line will be tangent to the graph. Okay? Now, why is this important? Because now I can literally just plug this into what k is. So k has two possibilities. K can either be, if I plug in plus 3, this will be positive 2. If I plug in minus 3 times 2 is minus 6, minus 4 is minus 10. So I get that. K is equal to 2 and negative 10. Does this make sense? So just to recap, what I did was I took the derivative of f. I set that equal to the slope of the line of interest to find k in generic terms. Then I rewrote f by substituting k in. Then I set f equal to the line of interest. By doing that, I'm able to obtain the points where the function equals the tangent line, because obviously whenever we have a tangent line, the function has to equal the tangent line, right? It's a system, right? This is actually a system of equations if you think about it. That's what we're doing here. And then by figuring out the x values at which the function itself is equal to the tangent line, we can plug those x values back into k, and we get the specific values. Ashwin, do you want me to go over number 11 as well, or do you want to try that on your own?
I'll try that.
Okay, good. All right. Okay. Anything else in this packet? Yeah, this is just applying rules. And once again, for problems like these, this one I would actually go ahead and some of these I would actually use the product rule, but sometimes if it's easy enough, I might just multiply it out and use the power rule. Like this one here, number 10. Number 10 is a crazy one. You shouldn't be using the product rule for this, all right? Number 10 right here, because you should immediately notice this as a plus b times a minus b, so it's a squared minus b squared. So this is just x minus 1, and the derivative of this is just 1. So there was no need to use the product rule in this. So whenever you can, please try to simplify it out. You'll make your life much more easier. Okay. Good. Anything else on this one? This one, it's asking you to find the 999th derivative of cos of x. What you'll have to do this, you guys remember how you can find, if I tell you what I to the 950th power is, you should be able to tell me what that is by dividing it by 4. It's using the same principle because the derivative of cos of x repeats, right? The first derivative of cos of x is minus sine x. The second derivative of cos of x is minus cos x. The third derivative of cos x is positive sine x. And then the fourth derivative of cos of x is just cos of x again. So it repeats. And using that pattern, you can divide this by 4, and then you can determine what the derivative is. Does that make sense? And same thing with sine of x. So that's how you do these problems. And then these ones are just, you just have to use these rules and work them out, and you can do that. Okay. So this is, I think, this is similar to what we did from the first packet. Let's do some of these real quick because once you know how to do these, like, it's much easier. So what is this function really saying? What is f of x in this one? F of x is just x squared, right? Because remember from the function, the definition, we remember it's f of x plus h minus f of x over h. So we know that f of x is just x squared, and f prime of x, which is what this limit is asking for, is 2x. That's why it's not actually asking you to solve the limit. It's what these problems are telling you to do is figure out what the functions are and then find their derivative. That's what these problems are telling you to do. Like this one, or let's try this one right here. Actually, let's try.
So just like for number 2, it would just be like secant squared x.
Exactly.
Okay.
Actually, this should be an x right here because if that was tan h, that wouldn't make sense. I don't know if you realize that, but by definition,
Okay, yeah.
Yeah. Okay. I think that's a typo there, but yeah, it should be sec squared x. Okay. And then the other ones, like these right here, once again, you just have to figure out, remember what the formula looks like the structure of the limit. This one is f of x minus f of a over x minus a, so f of x is the first one here. And here it's asking you to find the derivative at a specific point. So f of x here is equal to x squared. So f prime of x, but specifically here it's asking you for f prime of 5 because that's what the limit is, right? So f prime of 5 is equal to 10 because 2 times 5 is 10. Okay, all right. I think that's enough for this one. You guys can go back and then once again, if you guys have any questions, put it in the Slack and we can take a look at it. Okay, we'll go back to the other one now. Problem definition of derivatives. Okay. All right, let's go through. Give me specific problems because I don't want to go through the whole thing and do ones that you don't need to know.
One that I was really confused about was number 8.
Okay. Good. Where did the snipping tool go? Snipping tool. I think someone has to. Okay, Ashwin has to leave. All right, no problem, Ashwin. No problem, and I'll see you later. Okay. All right. Oh, I didn't even take a snipping of it, so that's not gonna work. Where is snipping tool? I know it's open, but I can't find. I don't see where it is. Oh, it's hiding behind Zoom. What? The thing we always get on Miss Raja for finally happened. You know how you know how it's like behind the video, and we're always like, it's just right there, and she's like, I can't see it. That happened to me. All right, number 8. Number 8. Okay.
What page is this?
I think this is on page 2 of the, but this is
That's
from the
page
previous
2.
problem set, not from the current.
Oh, I was so confused.
Okay.
So
So
I said now. Oh my goodness.
So tangent line, once again, tangent line means I'm going to take the derivative. The derivative, oh, on this one, she wanted you to actually use the limit definition. So you would, do we need to work through that right now? If we need to, okay, no, all right.
No, yeah.
Because
no.
it takes forever. But I hate working through all that. It takes forever to do that. So the derivative is
So
just 2x.
when she says that, does she mean like use the what's it called? Like, what does she mean when she says like use the limit definition? Or...
Oh, use the limit definition. So what that means is I need to write out the limit as x approaches, or sorry, not x. In this case, I'm going to use h. As h approaches 0 of f of x plus h, and then you have to work through the whole thing, which is just a pain.
Is there ever a time where we like have to use that?
Only when she tells you to use it. But
Okay.
no, it's good to know how to do it because you need to know how to actually do it. But you're not going to use it.
Okay.
Okay.
So that definitions of derivative, like how she made us do that, you don't have to do that.
That's just for the first one. For the first problem set, you have to use the limit definition.
Yeah.
But after that, you won't ever have to do that, unless it specifically says, unless they give you something like prove. Whenever you're doing proofs, you always have to refer to the original definition. So if they tell you prove that the derivative of tan of x is secant squared of x, then you would have to use the limit definition and then show that. All right. Okay. So for this one, f prime of x is 2x. Now the thing is, we're trying to find. So if I have 2x, right? So let's graph x squared first. So x squared looks something like this. I know that should be exactly at 0. I can't draw, so we're not going to spend time trying to fix that. 1, negative 3. So we have a point 1, negative 3. And it's saying that we need to find two tangent lines that pass through this point, but are not on f of f, right? So this, what she's telling you is that 1, negative 3 is not on f. Okay? So we're trying to find this tangent line. Once again, it should be passing through that point, but I'm so clumsy and I can't draw. So, and we're trying to find, here, I can't draw the angle properly, but okay, hypothetically, there would be another tangent line that touches f. Here, let me just redraw this, because this isn't working right now. So let me draw this a little bit closer.
She drew it on the paper, so I think we get it.
Okay, you get it. Okay, yeah. So it looks like that and like that. Pretend that's a straight line. I can't do this. So pretend that's a straight line, and we're trying to find the equations of these two tangent lines. Now the tangent line is always going to be 2x, right? So what we're trying to find is the points. Oh, so now we just use point slope form. Whenever you're trying to find tangent lines you use point slope form. Point slope form is y minus y1 equals m times x minus x1, right? So our x1 and y1 are given. We need our line to pass through these points. So y plus 3 equals m times x minus 1. So that's the equation of the tangent line. But we need to figure out what m is. And well, the slope is what? The derivative, right? Remember how in the last problem set when we were trying to figure out the value of k, we said the slope equal to the derivative. We're going to do the same thing here. We're going to say y plus 3 equals 2x times x minus 1. I don't think I'm doing this properly. Let me think about this one more time. I was confident in my method, but now something seems wrong. Does this seem right or wrong? This would be, if I simplified this out, this would be 2x squared minus 2x minus 3.
That's wrong.
That's wrong. This doesn't seem right.
I'm not sure.
Yeah, this doesn't, I'm not doing this properly.
The reason I was really confused is I think because the way she wrote it in the solutions, like I was really just like, I didn't understand what she was.
Okay, let me see, go back and see how I did this. This is number 8.
She used the definition of a limit formula. So she did a squared plus 3 over a minus 1 because, you know, you did that. If you're using the other form, right? The other form where you do like a squared. Do you know what I'm talking about? Like f of a, you do that.
Yeah.
So she used that, and she like, I don't exactly know what she did.
Yeah.
Oh, are we talking about the limit, like how she solved it?
Yeah.
Okay, let's go ahead and do that. Here, let me just start this problem from scratch. That way, because that way I have some more time to think about how to do this. Just let me tell you, this is how I do math. I literally have no idea how to do things, and I just kind of just think and work my way through it. So, hopefully the second time through, I'll have a better idea of how to do this. So the first thing is limit as, so let me write it out as f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. That's equal to the limit as, I'm not going to rewrite this because it takes time, the limit as h approaches 0 of x plus h whole squared minus x squared over h. That's equal to the limit as h approaches 0, and that's what the scribble stands for, is x squared plus 2xh plus h squared minus x squared over h. The x squared and minus x squared go away. Now we're same thing, limit as h approaches 0. I'm going to factor out an h, so it's now 2x plus h over h. That allows me to cancel the h, and we get limit as h approaches 0 of 2x plus h, and we substitute 0 into h, and we get 2x. That's where we get the derivative.
Wait, I actually know what she did. Okay, I figured it out. So she used the point slope formula, but instead of using the point 1, negative 3, she used a and a squared because we know the equation of the graph is x squared. So a and a squared have to be like a point, and then she to find the slope.
Okay. Yeah. We were heading in the right direction, right?
Yeah.
Yeah. Okay. I see what you're talking about. Okay. All right. Let me make this a little bit smaller so I have more room on my screen. Okay. All right. So we know that it's 2x, the derivative. So now what we were doing earlier, where we said, okay, we know that we need our slope. So once again, point slope form, y plus 3 equals m times x minus 1. That makes sense, right? How I got that? Okay. M is the slope, and m is just 2x. Oh, that didn't work. Let me just erase this. So m I can just write as 2x because that's our derivative. And y we know is x squared, right? So if we can figure out the specific x points at which this holds true, then we can figure out the specific y points as well later. So x squared plus 3 equals 2x squared minus 2x. And then we can say 0 is equal to, what? 2x squared, x squared minus 2x minus 3. Did I do that properly? And then that's equal to x plus 1 times x minus 3, I believe. So that means x is equal to negative 1 comma 3. That's our solution set for x. Now, if we're going to find the tangent line, now all we have to do is we still need to put it in point slope form, where it's y plus 3 equals 2x times x minus 1. But now that we have our x values, we can actually plug these into here to figure out the specific formula. So what the first equation is going to be y plus 3 equals negative 2 times x minus 1. And the other one's going to be y plus 3 equals 6 times x minus 1. And if you simplify these two out, the first one will be y equals negative 2x minus 1, I believe. And then the other one will be y equals 6x minus 6 minus 2 is minus 9. correct me if my arithmetic is wrong. So these are our two equations. This one and this one. Does that make sense how we got that, Alina?
Yeah, that makes sense.
So all these problems, they're all about substituting. So essentially the common theme is you take the derivative, you set it equal to the slope of the tangent line, and then you do some sort of comparison, and then you substitute, and then you solve.
Okay.
Okay.
Okay, so for finding the tangent lines when given a point,
Yes.
use this y minus like y1 equals m parentheses
Yeah.
x is x1. Okay.
So here's another thing. Say I was told, okay, forget about this, but using the same concept, if I have f of x equals x squared, now I want you to tell me what is the tangent line for x equals 3, right? The first thing I need to do is figure out the y value, because if I don't have a y value associated with x equals 3, I can't plug it into my point slope formula. So that's going to be equal to 9. So the simple thing I'm going to do is I'm going to say y minus 9 is equal to 6 times x minus 3. How did I get that 6? Well, the derivative of f of x is 2x, and if I plug in 3 here, I get 6.
Okay.
And then you can simplify this up.
Okay. But if it asks for like 2 tangent lines, then would we have to like do what we did? Like,
Well, the only reason it asks for 2 tangent lines is because that's like, even if the question had said find the equation of the tangent line that passes through whatever, you would have still resulted with 2 answers simply because that's how the thing works out. Does that make sense? Like in this case, because it was a quadratic, it happened where there were 2 x values, and that's why when you plug them in, you have 2 separate equations. That's why there's 2 tangent lines.
okay. So
That's not always going to be the case. You might have 3, you might have 1. It just depends.
So why couldn't, so like here where you just plugged 3 into 2x, why couldn't we like just plug 1 into 2x? Like yes, where it says like 1 comma negative 3.
Oh, because the thing is, 1 is not the point on our function. Remember, this is our function. The reason we were able to do it here is because x equals 3 was on 3 comma 9 was on our function. But that's why she said 1 comma negative 3 is here. We need to figure out the point corresponding to that on the function, which is why we took that's why we took x squared. That's why we took our point slope formula, substituted the y for x squared, and we solved for the points such that the tangent line would equal, that essentially the tangent line would cross through this point.
Okay. So just like a simple like definition, what's the difference between the tangent line and the normal line?
Okay, normal line is just the one that's perpendicular to it. So if I have
Perpendicular to the
this, so it would be here.
To the tangent line. It's just a perpendicular line.
But not any
And it-
perpendicular line. So
and it
like
goes
I
to the
can't,
point. It
yeah,
goes to
at
the
the point, exactly. So it can't, this is not a normal line. This isn't the normal line because the tangent line, it touches f at here, so I need the normal line to be here. So all you do when you're solving for normal line is say I wanted to, for this equation, y equals 6x minus 9, which would actually be this point right here. Actually, let's do the other one so I can draw it out. We'll finish up in 10 minutes. Okay, let's look at this one, y equals negative 2x minus 1. Let's say this one is y equals negative 2x minus 1, right? The normal line for this one would be, instead of relying on, you need to go back to the point slope formula. So it would have to be, you can't use 1 comma 3 anymore because 1 comma negative 3 is not on the function. You need to use negative 1 comma positive 1 because that is on the function, right? Negative 1 comma positive 1. So for this one, you would say y minus 1 equals, what would the slope be? Negative 2? Yeah, negative 2 times x plus 1.
Isn't it perpendicular?
Yeah,
I-
so we'll get, well, yeah, yeah. So this would be the tangent line here, right? In general, y minus 1 equals negative
Yeah.
2 times x plus 1. That would be the tangent line at this point. And actually, if you simplify this out, this and this should be the same, right? Because they're the same tangent. I just rewrote it in terms of this point. Now, like you were saying, you take the opposite reciprocal. So this would become half x minus 1, or x plus 1, I'm sorry. And then you would simplify this out, and that would be your normal.
Okay. Okay, yeah. I think I got it. Okay, I'm gonna be right back in like 2 minutes.
All right. Does anyone have any other questions about these? I'll wait for Alina to come back because I think she might have had something else. But otherwise, I think we're pretty much done. If you're asked to do things like these, where it's like sketch a graph of f prime of x, then what you want to do is, once again, figure out the points at which the derivative is 0, plot those, and then you want to think of the extreme points. So this is where the slope is the most negative. So I'm going to put a negative here. And then obviously we see from here to here, the slope is increasing. And then from here to here, the slope is increasing. So it's going to be positive here, negative here, and then positive here again. And that's how you figure out slopes for these. Okay? That's very simple, straight to the point right there.
MG?
Yeah.
For number 4, how would you find the parallel line?
Okay.
I get how to do the tangent, but
Sure. So equation of the line that is tangent to f of x equals x cubed. So we know that f prime of x equals 3x squared, right? Okay, f of x equals 3x squared, and the equation of the line that is tangent to that and parallel to y equals 3x plus 1. Okay, so we just need to find when f prime of x is parallel to this, right? So when is parallel? Parallel means the slopes are the same. So the slope here is 3, meaning that my derivative, which is the slope, needs to be set equal to 3, right? And x squared would be equal to 1, which means x is equal to plus or minus 1. That means at x equals plus or minus 1, that's when my function's tangent lines are parallel to 3x plus 1. Does that make sense?
Yeah.
So now to figure out the tangent lines, you would need to think, okay, for x equals plus 1, y equals plus 1, for x equals minus 1, y equals minus 1, and now I can put it in my point slope form where I have y minus 1 is equal to m. What would my slope be? Well, my slope is 3, right? My slope is 3. 3 times x minus 1. Then the other tangent line would be y plus 1 is equal to 3 times x minus 1. This one should have also had two answers, right? Correct me if I'm wrong. Did this one have 2 answers, like I got here?
I don't know. I haven't finished it.
Yeah, it had 2 answers, just like this. Okay. All right. I think Neha, did Neha leave? Yeah, Neha left. That's fine. I think she said on the, oh, Shruti left. Okay. Yeah, we'll wrap up real quick. Does anyone else have any other questions? Alina, did you have any other questions? Otherwise, we were going to wrap up.
No, I thank you. I think I got a lot of the stuff now. I think I just need to go over like the tangent line and stuff like that.
So I was telling Zachary, like, this one is another one where even though it says just find an equation of the line that is tangent to this, you'll actually get two answers because when you work it out, there's a positive and a negative version since it's quadratic.
Okay.
Okay. All right. That's pretty much it.
Thank you.
All right. Let me stop sharing. All right. Yeah. Once again, just let us know in the Slack if you have any questions. That's the easiest way to, So, and then, I'll try and sometimes I FaceTime or Zoom other people if one-on-one if they need additional help. So if you need that, let me know. If I have time, obviously, I know I have work to do. So if I have time, I'll definitely help. But yeah, just put it in the Slack if you have any other questions. All right. Good night, guys.
Okay, thank
Thanks,
you.
Mrigayu.
Thank you.
Bye.
Bye.